Hello, beta. Let us now go ahead and take an example where we will be dealing with many player game, right? So we want to go ahead and we want to find Nash equilibrium in this game. Read. There are only two Nash equilibriums. So please try to understand the game first, then I will talk about it. The game says that there are n players. And if all these n players are together looking for stag, they are together looking for stag. No one is looking for a smaller animal. All of them are looking together. They are hunting the big animal together. एक साथ कर रहे हैं. Only then they will be able to catch the stag. And if they will be catching the stag, only then they will be able to get the benefit from it. The benefit that each one of them will get from stag is more than the benefit that each one of them will get from small animal here. छोटे एनिमल से कम बेनिफिट है, बड़े एनिमल से ज्यादा बेनिफिट है. सो it is beneficial if all of them catch the stag. But if one less player catches the stag, मतलब एक player बोल दे कि नहीं 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 नहीं, I want to look for here, and only n minus 1 players look for stag, then they will not be able to catch the stag. तब उन्हें stag नहीं मिलेगा. They will not be able to catch the stag. So they will be able to go ahead and catch the stag only if all n players are available to catch the stag. अगर सब एक साथ मिलके ढूंढेंगे, hunt करेंगे, if all n players go ahead and look for the stag, only then they will be able to go ahead and get the stag. If one of them also deviates, then they cannot catch the stag. तो stag नहीं मिल पाएगा. But the player who is looking for here, smaller animal, he will get some payoff. Others will get zero payoff because they will not get any animal. वो कुछ भी hunt नहीं कर पाएंगे. They won't be able to hunt any of the animal. Is this clear? ठीक है. Now our aim is to go ahead and find Nash equilibrium of this game. हमें इस game का Nash equilibrium निकालना. So my claim is that there are exactly two Nash equilibrium. The first Nash equilibrium is where everyone is looking for a stag. So when everyone is looking for a stag, then the question is there any incentive to deviate? Answer is no. Suppose I tell you that player 1 deviates. Player 1 stag को नहीं ढूंढता, and he deviates and he starts looking for a hare. And other players, they continue looking for stag. Right? So this player who is deviating, his payoff from here, it is less than his payoff from stag. बड़े animals से उसको ज्यादा payoff मिल रहा था. His utility from here is less than his utility from stag. So will he deviate? जब बाकी सब stag ढूंढ ही रहे हैं, if he starts looking for a stag, he will be getting more payoff because they will be able to catch the stag. Right? तो क्योंकि वो stag को पकड़ पाएंगे, they will be able to catch the stag, there will be no incentive to deviate. Deviate करने का कोई incentive रहेगा ही नहीं. Right? So this will be a Nash equilibrium because no player has any incentive to deviate. कोई भी incentive नहीं है deviate करने का. My second claim is that here, everyone catching a hare is also a Nash equilibrium. ठीक है, अब देखो जरा ध्यान से समझो. When everyone is catching hare, तो हर एक को वो छोटा एनिमल मिल रहा है. Everyone is getting hare. Now suppose this person decides that I want to deviate. The first person says no, I want to deviate and I want to start looking for a stag. मुझे बड़ा एनिमल ढूंढना है. I want to look for a stag. So if this person deviates, अगर ये deviate करता है and he starts looking for a stag, what will happen, beta? He will get zero payoff. Why? Because individually you cannot search for a stag. आप अकेले में stag नहीं पकड़ सकते हो. You cannot catch a stag individually. So since this person will not be able to go ahead and catch the stag, he will be without any animal and बाकी सबको तो hare मिल ही रहा है. So will he have any incentive to deviate? No, right? Because when he deviates, he is not able to catch the stag alone. His payoff becomes zero. And when he is catching here, he is getting some payoff. Kuch payoff to mil raha hai. We will always look for incentive to deviate for one individual. एक बारी में एक को ही deviate करके देखोगे. You will always deviate one individual and check. So this individual by deviating gets a lower payoff. So this is also not, this is also a Nash equilibrium. Achha, suppose I ask you stag, 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 till stag, and one person here. Is this Nash equilibrium? Is this Nash equilibrium? No. Kyun? Because if I look at this last person, he is getting a hair, but he has incentive to deviate. क्योंकि अगर वो deviate कर जाता है and he helps others to catch a stag, then he will get higher payoff. Because others are catching stag. So if he deviates to catch a stag, they will get the stag. और जैसे stag मिलेगा, his utility from stag will be more than his utility from here. Right? So यहाँ पे he has an incentive to deviate. So this is not Nash. समझ रहे हो? So we have gone ahead and we have said that in any other profile means something like this. ठीक है? At least one player chooses stag and other one chooses here. At least एक player ने stag choose किया होगा और एक ने here choose किया होगा. A player is better off catching here than stag if at least one other person chooses here, since stag can be caught only if everyone pursues it. तो अब देखो, suppose I ask you this. समझो यहाँ पे इस example को. If I ask you, is the following Nash equilibrium? Is the following Nash equilibrium? And मैंने क्या बनाया यहाँ पे बच्चे? What am I making? I am doing something like this. Stag, stag, stag. Only last two people are for here. अब ध्यान से समझो, दो लोग हेयर के पीछे हैं, एक पॉइंट पे एक ही का डिविएशन देख सकते हैं. सो दीज टू आर गेटिंग पॉजिटिव यूटिलिटी क्योंकि इनको तो हेयर मिल रहा है. But these people are getting zero utility because they are not able to catch stag, because not everyone is catching stag. So what is best for this person? He will have incentive to deviate. ये deviate कर जाएगा. And he will go for his individual here. He will catch here. Right? This is what is written here. That if there is at least one more person who is choosing here, अगर कम से कम दो लोग here choose कर रहे हैं, so any individual who is choosing stag, he knows that they cannot catch stag, so he has an incentive to deviate. वो deviate करेगा and he will choose here. Is this making sense? So this is the multiplayer game that I am talking about. ठीक है, this is called as many player Nash equilibrium. ठीक है. Let us go ahead and let us take another example of many player Nash equilibrium, beta. And this is going to be the provision of public good. Public good के provision की बात करते हैं. So there are n people choosing to contribute fixed amount towards the public good. तो देखो, there are n people. And they have to contribute and make a public good. Good provided where k individuals contribute to the public good. So suppose I tell you that n is 10 and suppose I tell you k is 6. माने in 10 लोगों में से, out of these 10 people, if k, which means 6 people contribute, then good will be created. ये public good बन जाएगा. If out of 10 people, 6 people contribute, then we will have public good at place, right? Okay. The best option for any person is when he doesn't contribute and good is provided. So because only 6 people are required to contribute, so what will this person think? Ki, let me not contribute. Others can contribute, and if I still get the good, still get this public good, then this is the best option for me. What is this called in microeconomics? We have studied this. इसको बोल देते हैं हम free rider problem. Right? This is my free rider problem, isn't it? So this is exactly what we are saying, that the best outcome for any individual is when the person doesn't contribute and the good is provided. Good bhi mil gaya aur person ne contribute bhi nahi kiya. The second option is when he contributes and good is provided. यहाँ not नहीं होगा. When he contributes and good is provided. Contribute किया and he gets the good. The third option is he doesn't contribute and no good is provided, right? And the last is he does not contribute and last is when he contributes but good is not provided. ठीक है, तो एक बार दोबारा देख लो. देखो, best. What is the best option? So these are 10 people. These 6 people, they contributed. इन्होंने contribute किया. This person free rided. इसने contribute नहीं किया. He is a free rider. हाँ, good create हो गया. Public good is created. He will also get benefit from the good. है ना? He is most happy. Right? This is the first best option. When good person is not contributing and the good is provided. Second में, among the 6 people who contributed, this person was there. He had contributed. And फिर good भी बन गया. So he contributed, he gave money to the government and good came. So that's the second best option. Second best option. That he contributed and public good was provided. Third thing that can happen. The third thing that can happen is now, basically, he has contributed. He thought that I will not contribute. And we saw that instead of 6, only 5 people contributed. Enough contribution did not came. 5 लोगों ने contribute किया और 5 ने नहीं किया, but he didn't contribute. Right? So no contribution and public good also not provided. Right? And fourth option. Fourth is, among the 5 people who contributed, he was among them. ये इसने contribute तो किया, but contribution only came from 5 people. Right? So contribution, but public good not provided. Now my question to you is that if I give you such a game, if I tell you such a game for the provision of the public good, what do you think is going to be a Nash equilibrium? Kya hoga Nash? So answer is, there are 2 Nash equilibrium. First, an action in which exactly k people contribute is a Nash equilibrium. So for example, n is 10, k is 6. So I am saying my Nash equilibrium is something like this. 6 people contribute and 4 people don't contribute. And I am saying that this is my Nash. Here, no individual has an incentive to deviate. No one has an incentive to deviate. किसी को deviate करना ही नहीं है. Let's see. Consider this individual who's contributing. If he deviates, तो क्या हो जाएगा? No contribution, contribute, 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 contribute. No contribute, no contribute, no contribute, no contribute. So if he deviates, माने he is not contributing. So now exactly 5 people contribute. So when 5 people contribute, माने the good is not there. That means no public good. But क्या preference था? Getting public good is better. Just see here. When you contribute and you get the public good, this is better over not contributing and not getting the public good. तो उसने contribute तो नहीं किया. This person deviated. Public good भी नहीं बना. But this is a worse outcome. This was better when he was contributing and public good was there. That means this person who's contributing, he doesn't have incentive to deviate, because when he deviates, his payoff is lower. His payoff reduces. Samjhe? Let us take another example. Now consider any person who is not contributing. Will they want to contribute? नहीं, public good भी मिल रहा है और contribution भी नहीं करना. You're getting the public good and you're not contributing. There is no reason why you will start contributing, right? You are currently here. You are currently at the first best. That means you are not contributing and getting the public good. Why will you want to go to the second best where you contribute? There is no reason. So that means this individual, he is free rider. He is getting public good plus not contributing, right? This is his best thing. So he doesn't have incentive to deviate. He will also not deviate. कोई reason ही नहीं है why he will deviate, right? He has no incentive to deviate, right? ठीक है. Now the second Nash equilibrium is where no one is contributing. So 10 people not contribute, 2, 3, 4, 5, and everyone not contributes. Why is this a Nash equilibrium? Because let's consider any one individual. See, if he deviates, then what will he do? Deviation से क्या होगा? He will end up contributing. So if he contributes, it will be like this: contribute, not contribute, not contribute, not contribute, till not contribute. Isn't it? But if he contributes, he is the only one who is contributing. We needed 6 people. So there will be no public good. So he will be here in the fourth outcome. He contributed and no public good. Isn't this better? When he was not contributing, sorry, he will be here, contribute and no public good. Isn't this better? Not contribute and no public good. ये ज़्यादा better equation था, better solution था. So it means that he has no incentive to deviate. So here he contributes and no public good is provided. Therefore, he has no incentive to deviate. Okay, now I have a question for you. What if all contribute? Is this a Nash equilibrium? Contribute, contribute, contribute 10 times. What if all people contribute? Is this a Nash equilibrium? क्या ये Nash है? Think. The answer is no. Why is this not a Nash equilibrium? क्यों सबका contribute करना Nash नहीं है? Because this one person, he can deviate. If he deviates, what will be the outcome? Not contribute, 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 and till end contribute. So if this person deviates, still 9 people are contributing. We needed only the contribution from 6. Matlab public good will be provided. But no contribution from this person. So he is free riding. So he is in outcome number 1. He is here. When he is getting the public good and he is not contributing. So why will he go to outcome number 2, where he contributes and get the public good? There is no reason, right? So we can go ahead and we can say here that here he has an incentive to deviate. So all people contributing is not a Nash equilibrium in this case. You just have to check whether people have incentive to deviate or not. अगर इंसेंटिव टू डिविएट नहीं है तो नैश, और अगर है तो नॉट नैश, राइट? So these are two examples I wanted to discuss related to many player Nash equilibrium.